I'm going to welcome Nadjim Brahmi from SoftAtHome up here, who's going to be talking about Ambiorix.
Please welcome.
Thank you so much. Thank you.
Yeah. Hi, everyone. Thank you for being here. So, yeah, I'm Nadjim Brahmi, and I'm a field application engineer working for SoftAtHome. Today, we give you a presentation of Ambiorix framework. So, I will start by giving you a global overview of what is Ambiorix, and then we'll go together to see a practical part and to implement an application based on Ambiorix from scratch. So, yeah, as you know, most recent routers support more and more new features like smart Wi-Fi, like QoS, and some other cloud features. And this what makes the software of a router more and more complex, because it contains a lot of microservices, as we can see here, and all these services, they need to communicate between each other. And thanks to a broadband forum, we have a unique way to define all these services, and this definition is described under Tier 181 data model. Here we can see an example of one of the services. We have the MQTT service, and we can see that on this Tier 181 data model, the MQTT service supports multiple instances of client, and each instance of client provides a set of parameters like a broker port, a broker address, and so on. Now, moving to prpl OS as a modern embedded operating system, it's assigned a specific part of this Tier 181 data model to an individual microservice. For example, we can have the DSCPv4, PPP, or one manager service, and all these three services, they need to communicate over USB. Now, the question is how this communication can be done. This communication is described on Tier 369 protocol, as it provides a standard command that should be supported by all of these services. These commands are defined here. So we have get, set, add, delete, and so on. And this what gives a way to exchange data between all these services. Now, these commands are supported and are implemented, we have to find a way to connect these different services. As these services are running on a different process, so we need to use one of the inter-process communication protocol, like a socket or any system bus. In our case, as prpl OS based on OpenWRT, and we know that OpenWRT provide a U-bus as system bus, so this is what will be used to connect these services. But U-bus itself doesn't give a way to implement data model as defined on Tier 181 protocol. And here, where Ambiorix came, because Ambiorix, in addition to support the default USB command, it also gives a way to define data model using ODL files. Yeah. So, yeah. Now you may wonder why Ambiorix. Because in the past, Ambiorix was a very famous Belgian king. He succeeded to unify all the Belgian tribes to fight against the Roman invader. But in our case, Ambiorix will unify all the bus system like U-bus, D-bus, Airbus, and any other proprietary bus to be able to build an application on top of Ambiorix. For example, here we can see that we can build the same application using the Humax bus abstraction library, regardless of what is the backend bus. We can also put our application on a container and install it over USB broker. So to summarize, we can say that Ambiorix is an open source C framework. It is more and more used. It provides a collection of library and tools like generic data containers, like bus and protocol abstraction layer. It provides a data model engine, and it provides also tools to interact with this data model. And Ambiorix focus on modularity because it simplifies creation of add-ons. So let's have a look on what are the different tools provided by Ambiorix to interact with the data model. The first tool is a command line interface. It can be used if you have a terminal open on a router like SSH or serial terminal. Its name is BIA CLI. BIA is for bus agnostic. The other tool is a fast common gateway interface. It allows the web UI to interact with the data model over a socket. It also gives a way to a USB controller to interact with data model using USB agent. And last, Ambiorix gives a lot of helpers to interact with the data model using C or Rust programming. Now we can go to our practical part. In this demo, we see together how we can build a complete application running on using Ambiorix. In our case, this application will be running on a container, on an Ambiorix container. This container is open source, so everyone can pull it and can use it. On this container, we have the same environment as a router. So we have Linux OS, we have UBus, and we have all the Ambiorix framework. At the end of this demo, we will have a complete application, and in the next demonstration, you will see with Fabrice how you can install this application using LCM over a USB broker. But in our case, our demo will be split in 3 parts. The first part, we will see together how we can use the generic Ambiorix data structure, which is a variant. And then we'll start to build our application. We'll start by building a very simple application, and then we'll add to this validation, events, and different commands. Once our application is ready to use, we will see how we can interact with this application over another Ambiorix client using UBus. So now we can start with the demo. So the first part is a variant. What is a variant? A variant is an Ambiorix data structure. It supports a lot of data type. The default data type as string, integers, bool, and so on. It also supports more complex type like IMX list, which contains a linked list of a variant. And it also supports Ambiorix hash table, which contains a hash table of a variant. In our demo, we see together how we can build this variant, which is combination of hash tables, string, integer, and bool. So this, you can see this demo on all these different screens, and we can go to the demo. Okay, good. Yeah. Okay, so here we can go to our first demo and see together that we have a basic main file where we will be building our variant. So as we can see, to work with variant, we need to declare the variant, initialize it, and then we'll start building the variant using this function. So to build our variant, we'll be using the IMX C var add k, where we'll add the different keys, and we will define what is the type of this key. For example, the local agent is a type of hash tables. Parameter is a type of hash tables, and then we will add to this parameter 2k enable status, and both of them are string. And we will finish by adding the other keys, which are bool and integers. Once our variant is built, we'll print it on the standard output standard using IMX C var dump. So this is, we can go to our okay, yeah. So here we are on the container, Ambiorix container, which is running on this laptop, and we can go to the first demo and see the output of the binary. So we have a script run demo. We can see that this script is just compiling the main.c using the lib Ambiorix and then executing the binary. Yes. So as we can see here, our variant look the same as what we wanted to build. So now we can move to the next step. In this step, we'll see together how we can define a very simple service which will connect to the U-bus and publish a data model. To do so, we'll be using the ODL file. It's one of the tools provided by Ambiorix. In the ODL file, we have 3 different sections which can be used. The first section is the configuration section. It will be used to put all the configuration related to the service, like the name of the service, the storage path, the different log level, and so on. The second section, it's the definition section. Here we'll be defining our application. In our case, our application will be a phone book app where we will store our contacts. And then we have the populate section. Here it will be used to define default value, if there is any default value. It will be used to set an entry point function to our application, and also it will be used to work with events. Okay, so okay. Now we can go to the demo and see how our service is defined. We don't see this screen. Okay, good. So here we have our define publish service, where we can see that we just need a very simple ODL file where we define the object name, its phone book, and we have a template of contact, because we can have multiple contacts on our phone book. Each contact has first name, last name, phone numbers, and email. So now we can go to our demo and we'll run our service. Yeah. So here we started our service, and in the second terminal we are also on the container, and we are executing it as a root user. And here, as we said before, we have different tools to interact with the data model, and we will be using one of those tools, which is BACLI tool. Just change the French better. Yep. So here we have a command line interface where we can see all the object under which are subscribed to this U-bus, and we have our phone book application. In our case, as we know that we have U-bus which is running on, we can also use another tool which is U-bus CLI. So using U-bus CLI is the same as BACLI, but BACLI is agnostic bus. So you don't care what is the bus using behind. So we can go and check that we have our phone book object, which is present on the U-bus. And for now, there is no any contact. We can add new contact using plus, and then we can see that we have new contact without any value. We can also, using this option, we can check that this phone book is supporting this Ambiorix defined all the default USB commands like execute, add, delete, describe. So you don't need to define them. It is done by Ambiorix. Now, once we created our contact, we can set the different parameter. For example, first name. We can put and same. We can also last name. Okay, and we can dump our object using the dump option, specifying P for parameter and R for recursive. So here we can see that our object contains one contact with first name, last name as defined here. Okay, now we can go to the validation part. The question is, why do we need validation? Because in tier 181, there is some restriction for some parameter. We can have, for example, one parameter which contains a number of enumeration value, or we can have restriction on length of a value, and this is already supported by Ambiorix. So you can define for each parameter on the ODL file which validation you want to apply on this parameter using the onAction validate, and we don't see it, but yeah, onAction validate call, and then we can call the validation we want to apply. So we can validate the length of a value, we can validate the enumeration of values. In our case, we will use a regular expression. So we want to validate that our value is matching a defined regular expression for our phone number and also for the email, because we want to have a valid email and valid phone number. You can also define your own validation. If you have any custom validation, it can be defined using the same call, onAction validate call, and then you define the name of your callback, the validation. You just need to implement your validation on the C file, and it will work. So now we can go to the demo, and we can see that in our case, we have added two validation. We wanted to validate that the phone number contains only 8 to 16 digits, and then our email contains a correct email format. We can go to the application and see. Okay. Okay, now we have run our phone book service, and let's see if we can add a new contact with a wrong phone number, for example. So we need to add the new phone numbers, and in this phone number we can set, for example, like this number, which should not be accepted. So as we can see here, this value is not accepted by Ambiorix because it doesn't match the regex. Now we can set a valid phone number. For example, we can set this phone number, and we can see that here this number is accepted by Ambiorix. And if we check the value, we can see that we have the correct value. And it's the same for the email. Okay, so yes. So now we go to the event. In most of the case, when we are working with Ambiorix or we wanted to implement some services, we need to execute a dedicated action for specific events. In our case, Ambiorix give support these events which can be raised for all those. For example, if any new instance is created, we'll get an event DM instance, new instance added. And if one parameter of our object was updated, we will get the event object change value. So in our application, yes, you can subscribe to event using two different ways. In the case of you wanted to execute the same action for the same event on the whole life of your service, in this case, you will define it on the ODL file on the populate section using this format. On event, and then use event name, call, the function you want to call, and then you can add a filter to match regex. But if you wanted to subscribe or unsubscribe to some events dynamically, in this case, you need to do it on the C file using the libimxp. And this library is well documented on the prpl Foundation, so it will be easy to use. So now we can go to our demo and see the event we have implemented. Yes. Okay. Okay. So this is our application. We are using the same phonebook app where we have added the populate section and we have defined 3 different callbacks for 3 different events. The first one, we want to print event using the asterisk. It means we wanted to print all events received on this object. And then the second callback, contact added. We wanted to call this callback when each time a new contact is created. And the last callback is contact type changed. This callback will be called for every time the parameter type was updated. Now we can go to the C file and see how these 3 callbacks are defined. The first one, we're just dumping the data which contains all the data of our event on the std out. The second, the contact added. Each time a new contact is created, we wanted to dump the last name, first name, and the type value. And the last callback, contact type changed. In this case, we want to print the old value of the type and the new value of the type. Let's go and see this event. Okay. Okay. So here we can see that the first callback is called because each time a new app starts, we received the event signal received app start event. And then we can go to our phone book and add new contact and see which event will be. Okay. So here we can see that we received the event of object added, where we have the signal data which contains all the data, all the object information. Now, let's update the value of the type. So for now, the type is value of unknown. Let's put family. As we can see here, we received the event object changed, and we are displaying the old value of event. It was unknown, and the new value of the event, it's family. So it works. And yeah. Now we can go to the last part of our application. It is command. So in most of the case, when we are implementing application, we wanted to execute a complex function using a single call. In this case, Ambiorix give a way to implement this using data model and using a command. To define a command, we need to respect this syntax, which should be the return value of the command, the name of the command, and then the different argument. You can also, for each argument, you can set different attributes. For example, if you want to define an argument as an input argument, so we can use the in and the out for the output argument, and also you can use the mandatory attribute if you want to set a mandatory argument. In our case, we'll add 3 different commands for our service: the add contact, the save, and the load. The first one, we wanted to create a new contact with a single call and defining all the data on the parameter of the command, and then the other command will be used to save and load our data model. So here we can go to the application, to the command, and this is our ODL file, the phone book ODL file. In the definition section, we have defined the 3 commands: add contact, and save, and load. And then on the source, we can go to the source file and see how this command are implemented. So the add contact we just need to get from the args the argument of the command. In our case, it will be first name, last name, and a list of phones and emails. And then using a transaction, we'll create a new contact using the add instance function, and for each contact, we'll set it as the argument. And same for the save and load. For the save, we'll get the file path where we want to save our data model, and then using IMXO library, IMXO parser save object, we'll save our object on a data model. And the load will be the same. We'll get from the arguments, we get the file name which contains the ODL file, and then using the IMXO parse file, we will parse the file and we will load our data model. So let's see it on the container. So here we have the command demo. Need to execute the phone book, and here we can see that our phone book supports the new command add contact, load, and save. Let's add a new contact, giving first name, last name, and a phone should be list of phones, so we need to use bracket, and let's use any phone number. So as we defined that email are not mandatory on the ODL file, so this command should success without giving the email value. So as we can see here, we have this command is well executed, and we can see that our phone book was updated with the correct contact value, first name, last name, and phone number. And of course, if we try to add a new contact without specifying one of the mandatory parameters, it should fail, as we can see here, because the first name was part of mandatory parameter. Yes. So at this point, our application is ready to use, and now we see how we can interact with this service from another Ambiorix application over UBus. So the first client will not be providing any data model. It will just be a binary which will load the UBus backend, connect to the bus, and using the IMXB function will interact with our phone book service. Yes. So in this demo, our client will send a request to our phone book service to create a new contact by specifying, for example, John Jones as first name and last name. So to do so, you can go to the demo and see our client. So to define a very simple client without using ODL file, first of all, we need to initialize the client, the connection to the bus, and then execute the different actions. In the init function, we'll be using the IMXB load to load the UBus backend. So in our case, we are using UBus, so we're loading the UBus ASO file, and then using IMXB connect, we'll connect to the correct URI where we have the UBus socket. And then once our client is well initialized, we can, using IMXB library, we can call the function to add a new contact. Yes, here. So we'll be using the IMXB add, defining the bus context we get from our initialization function, the object we wanted to connect on, which is phonebook.contact, and then we'll be providing the first name and last name from the argument. Now we can go to the demo. So first of all, we need to run the phone book in the background and then interact with this phone book using our client. So we can go to the first sample one, run it in background. So here we can see that our phone book is present without any contact. And now we can go to the client and run the binary. We can see that our client is well started and it has created the phone book contact, the first phone book contact on the phone book object. Now we can go to on our object and check. As we can see here, we received a query from a client which requested to create a new contact, and this is what was done on our service. Now, second part of client, we'll see how we can subscribe for different events from client to server. And to do so, we need to use the IMXB subscribe function, and we can define the notification we want to subscribe on. In our case, we want to subscribe if a new instance is added, and we wanted to add more filters because we want to be notified if this instance has as first name Elliot. So we can go to the demo and go to the subscription part, run the demo. So we have received all these notification value, but we are interested about the add instance notification. So let's add a new contact specifying the first name as Elliot. As we can see here, our client received the correct notification, the instance added, and we get the correct value of first name, which is Elliot. And of course, if we create another client without specifying the correct first name, we will not be receiving any notification. So, yeah, we reached the end of our demo. I hope it was clear and it was helpful. All the Ambiorix documentation is present under prpl Foundation GitLab. We can say that Ambiorix is the standard use on if we are working on prpl OS. Ambiorix gives a lot of gives an abstraction layer for different bus, and now you can use Ambiorix. Thank you so much.